I welcome everyone to my presentation about bioelectrical signal measurement. Bioelectrical signal is the sum of change in voltage across the cell membrane. The sources of bioelectrical signals are heart, brain, muscles, and eyes. This is the typical setup for measuring any bioelectrical signal. For measuring biological signals, highly sensitive and accurate devices are used. Recording electrodes makes ionic conduction at the tissue to the electronic conduction. Recording electrodes are classified into two types: invasive and non-invasive electrodes. Non-invasive electrodes are placed on the outer skin layer. Invasive electrodes are fixed in the body in such a way that it bypasses the outer skin layer. In order to avoid movement artifacts and to obtain clearly established contact, an electrolyte or electrode paste is usually employed as an interface between the electrode and the surface of the source of the signal. Electrode tissue interface is divided into metal electrode interface and electrolyte tissue interface. In metal electrolyte interface, there is a tendency for each electrode to discharge ions into the solution and for the ions in the electrolyte to combine with each electrode. The net result is the creation of charge gradient at each electrode, which is also called electrical double layer. The electrolyte tissue interface also produces the capacitance effect and stores charge. The potential developed in electrode tissue interface is called the electrode offset potential. The skin contact impedance is the combined resistive and capacitive effects of electrode skin junction. Contact impedance depends on the area of electrodes and the signal frequency. Contact impedance is reduced by the application of electrolyte or using invasive electrodes. The total impedance of the circuit becomes low in the presence of signal. The electrode offset potential produced between electrodes may be unstable and unpredictable. The long-term change in the potential appears as baseline drift and the short-term changes as noise on the recorded trace. So the electrode-electrolyte pair that makes least offset potential must be chosen. Thank you.